All right, guys, let's look at how we can do an example here. At school 1, 70% of students did their homework last night. Suppose that two counselors at this same school, Michelle and Julie, independently take a random sample of 100 students from their school and record the proportion of students that did their homework last night. When they are finished, they find that the difference in their proportions, p hat m minus p hat j, was 0.08. They were surprised to get a difference this big, considering they were sampling from the same population. We need to do three things. Describe the shape, center, and spread of our sampling distribution of the difference between two proportions. Find the probability of getting two proportions that are at least 0.08 apart. And should the counselors have been surprised to get a difference this big? Of course, we should start where we always do, which is to talk about the numbers in the problem. So we have Michelle and we have Julie. What we know is that they both sampled 100 students. So N Michelle, the sample size for Michelle is 100, and NJ, our sample size for Julie, is 100. We know that they were sampling from the same population, and that population had 70% of the students doing their homework last night. That is our true proportion, which means PM, the true proportion for Michelle, is 70.7, 0.7. And the true proportion for Julie is also 0.7. Then their statistics, p hat m is unknown and p hat j is unknown, but we do know that p hat m minus p hat j is 0.08. Take a minute to think about what this means. That means that whatever statistic they gathered, they were 8% apart. So an example, like one possible example, is that Michelle sampled and she talked to maybe a bunch of freshmen who all really did their homework, and she got 0.87. And then Julie talked to a bunch of students and they were not freshmen, so there were less of them who did their homework. And if Michelle minus Julie was 8%, then Julie's sample proportion would have had to have been 0.79. Right? That these two are 8% apart. That is one example. We don't know what they did, but that is a possibility. All right, for A, we are asked to talk about the shape, center, and spread for the sampling distribution of the difference between two proportions, namely p hat m minus p hat j. Let's start with our shape. We know that if n times p and n times 1 minus p, if both of those are greater than or equal to 10, our sampling distribution is approximately normal. Now, because nm, Michelle's sample size, is the same as Julie's sample size, and their true proportions are the same, we technically don't need to write out our things twice. It's important to note that those two things are the same, but then you can simply write the following. So the sample size for Michelle, we'll say, times the proportion for Michelle would be equal to 100 times 0.7. That would be 70 students. And NM times 1 minus PM would be 100 times 0.3, which is 30. Obviously, both of those are 10. And because this is the same for Julie, we can say that our sampling distribution is approximately normal. Our center, the mean of the sampling distribution of the difference between two proportions, would be equal to the mean of Michelle's minus the mean of Julie's, which is equal to the true proportion of Michelle's minus the true proportion of Julie's, or 0.7 minus 0.7, which is 0. Now think about that for a second. What are we expecting? Well, if Michelle and Julie are counselors from the same school, I think it makes sense to say that their difference in proportion, you would expect it to be 0, right? I would expect their samples to look similar because we're taking them from the same population. So this being 0 feels pretty good. Last but not least is our spread. The standard deviation of the difference between two proportions will be equal to the square root of PM times 1 minus PM all over NM, Michelle, and then PJ times 1 minus PJ all over NJ for Julie. I am not going to take the time to write down all those numbers. I would love for you to pause the video, take some time to type those into your calculator, see what you get. I got 0.065 as my standard deviation. And remember, this is true if our 10% condition holds. So again, because Michelle and Julie sampled the same size, we can check this once, that our sample size of Michelle will say needs to be less than or equal to 1/10 of our population. That means in this problem, our population needs to be at least 1,000, which I would say is plausible at a school that there are more than 1,000 students. Obviously, we do not have more than 1,000 students, but it is not crazy for the school to have more than 1,000 students. For B, we are asked to find the probability of getting two proportions that are at least 0.08 apart. The probability of getting two statistics that are 8% different or more. To think about this, I'm going to have us start by drawing our sampling distribution. So here's what we know. We know that this sampling distribution is approximately normal. We know that its center, the mean of p hat m minus p hat j, is 0. We know that its standard deviation of p hat m minus p hat j is 0.065, at least 8% apart. Well, if we look at this center being 0, 8%, I don't know, is maybe right here, 0.08. We are looking for the probability of getting a sample proportion of at least 8%, meaning 8% or more. So I know I'm going to shade over here. This is the probability that we get a p hat m minus p hat j, a sample proportion that is at least 8%. That is greater than or equal to 0.08. That's our green percent. But there is a small catch here, because in this case, in this time, Michelle's statistic is greater than Julie's, which would have to be true if their difference is positive, right? We had said one example was that Michelle, I think we said 87. Michelle talks to a group and 87% of them did their homework. And then Julie talks to a group and 79% did their homework. And because Michelle's was greater than Julie's, the difference would be positive. But that's not the only way that these two could get a difference of at least 8%, right? If Michelle, maybe Michelle sampled and she got 65% did their homework. And then Julie sampled and got that 73% did their homework. In this case, they are 8% apart from each other, but Julie is greater than Michelle. So we need to think of this option. And if Julie's proportion is greater than Michelle's, their difference would be negative, right? Think about that for a second. I still need to do this order, p hat m minus p hat j, but if I use these two proportions, if I do 65 minus 73, I'm going to get negative 8%, which would be over here, negative 0.08. And if I want to get a difference of at least 8%, I want to calculate 8% or more, which again, if we're talking about negative, is going to be less than that, right? So like 10% of a difference, if it's a negative difference, is to the left. This is the probability that p hat m minus p hat j is less than or equal to negative 0.8%. This is what we need to calculate. In order to do this, of course, we're going to use our normal CDF. This should be an obvious thing because we are looking to find the area under a curve, a probability from a normal distribution. And because this distribution is symmetric, we do not need to find both. You can find one and multiply it by 2. So I'm going to choose to write this one. This would be normal CDF. Our lower is 0.08. Our upper is a really big number. Our mean is 0, and our standard deviation is 0.065. When you do these things in your calculator, you calculate this area to be 0.109. Again, that is giving just this green area, but we technically need the green and the blue. So we're going to take this and multiply it by 2 to get our real answer of 0.218. There is a 21, actually we can write this down. There is a 21, oh please write, there is a 21.8% chance that Michelle and Julie get two samples, get two sample proportions that are at least 8% apart. C is an interesting question. C then says, should the counselors have been surprised to get a difference this big? Of course, I would ask you to turn to the person next to you in class and think about it. So pause the video if you want. But think about what we are saying. There's a 22% chance that this would happen. It did happen. Should we be surprised? I would say no. 22% is pretty high, right? Michelle and Julie should not be surprised. Michelle and Julie should not be surprised. They would expect, they should expect this to happen about 22% of the time. That's almost 1/5, right? That's a pretty high proportion. That's a pretty high probability. This question is essentially leading us to our significance tests, right? Should we be surprised if something happens, if it's likely to happen? No. Should we be surprised if something happens, if it's unlikely to happen? Yes. In the next video, you're going to learn about confidence intervals.